1.2b, we're going to look at another example. We're going to take the limit of the square root of x squared minus 3x plus 2 as x approaches 0. Okay, but the square root of this equation is also going to be continuous, so we're going to evaluate it by putting 0 in, and that ends up with square root of 2. Okay, so recall we had learned that the limit as x approaches infinity of 1 over x equals 0. Now, if you don't remember why, let's take a quick look at that. X 1 over x. If we put in a 1 into here, we get 1. If we put 10, we get 1/10. If we put 100, we get 1/100th. And we can see this is getting closer and closer to 0. So the limit of 1 over x as x approaches infinity is 0. Okay, so let's move forward. We're going to use this concept in solving some other problems. Okay, so here we go. We have the limit of, in the numerator, we're going to have x squared plus 4x minus 5. And in the denominator, 2x squared plus x plus 1. And all of this is going to be as x approaches infinity. So because x is approaching infinity, we can't just evaluate. We're going to have to go a bit further. So there's a little trick to do this. All right? What I'm going to do, and it'll make sense when you see it later, I'm going to divide the numerator and the denominator by x squared. Okay? And I'll show you how that works in a minute. It'll make all sense after we do it. So we're going to go ahead and write this in. Okay, so go ahead and write that. We haven't changed any value. This right here is just 1, right? We're multiplying the top and the bottom by the same thing. That's legal. Okay, so let's see what happens when we do that. The limit as x approaches infinity. And now we're going to distribute this to each term inside. Okay, so we have 1 over x squared times x squared. Then we have plus 1 over x squared times 4x. And then we have minus, because there's a minus right there, minus 1 over x squared times 5. Okay, so there's the numerator. Let's do the same thing to the denominator. 1 over x squared times 2x squared plus 1 over x squared times x plus 1 over x squared times 1. All right, so let's simplify what we just did in the next step. Limit as x approaches infinity. Now we're going to simplify. Notice, what is x squared times 1 over x squared? That's right, it's just 1. X squared times 1 over x squared is 1. All right? Then we go on to the next one. These x right here, there's an x that cancels out, and we're left with a 4 in the numerator and an x in the denominator. 4x times 1 over x squared is 4 over x, because these x's cancel out, one of them do. And the 4, of course, goes in the numerator. All right, let's continue. Now we have minus, because of that minus sign, 5 over x squared. Now let's do the same thing to the denominator. We have 2x squared times x squared, which is just 2. All right. In the next one, we have x times 1 over x squared. One of those x's is going to cancel, so we're left with 1 over x. And then the last one is 1 over x squared. Okay, so now we're going to look at x approaches infinity. Well, that's not going to change the 1, right? That can't do anything. If we put x is approaching infinity in this denominator, remember all of this goes to 0. All right, as this number gets bigger, 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 this whole thing gets smaller, 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 and goes towards 0. So we write 0. Now the same thing happens here. As this number gets bigger, bigger, bigger in the denominator, the whole number becomes closer and closer to 0. Okay, so we're going to do this again. Here, x approaches infinity. This doesn't change because there's no variable here. As x approaches infinity here, this whole thing goes to 0. And this whole thing goes to 0. So our answer is 1/2.